Hey guys, welcome to lecture number 10. So in this lecture, we will be talking about, we will continue our adventure in the world of derivatives. And last time you have seen how to compute derivatives of elementary functions, but also how to apply the rules of differentiation. You saw the sum or the difference rule, the product or the quotient rule. Well, in this lecture today, we will talk about derivatives of trigonometric functions, exponential functions, and also logarithmic functions. And we would like to see how we will apply the rules that we have previously learned in the last lecture involving these new functions. All right, so let's get started. So let me start first with something easy. So I would like to start with derivatives of trigonometric functions. And of course, when I talk about derivatives of trigonometric functions, I will be talking about first about these two functions, about sine and cosine. And look here. In other words, as you can see, the derivative with respect to x of the sine function will be the cosine function, and the derivative with respect to x of the cosine function is nothing else than just the negative sine function. So keep this in mind. In fact, we will even prove this. So that's what you need to know. So in other words, so these are very, very important. So in other words, you can write that sine of x prime, right? It is cosine of x, right? Or you can say that cosine of x prime will be nothing else than just negative sine of x. So keep this in mind. Right? So once again, the derivative of sine is cosine of x, and the derivative of cosine of x is negative sine. So, okay. Well, let's prove this. We would like to see at some point, you know, I think I made a mistake at some point. I don't remember, I did not remember which one was had the negative. It was sine or cosine, I did not remember that. But there is a way for you to prove this, and in fact, we would like to prove this. So these are the rules. So usually I didn't cover too many proofs in this course, but I think this deserves a proof. So we would like to prove that the derivative of the function sine of x with respect to x, right, is cosine of x. And of course, the tool that we have in our mind is to use the definition of the derivative, right? Remember the definition of the derivative? It was something like this: lim as h approaches 0 of f of x plus h minus f of x over h. Or if you want, you can also in other notation, so that's the derivative of f at the point x, or similarly you can write the lim as delta x approaches 0 of f of x plus delta x minus f of x, everything over delta x. Instead of h, you can write delta x. So this is the definition of the derivative that I had in mind, right, that I'm talking about here. And we would like to use this to prove that the derivative of sine is cosine. So let's do it. So let's use the definition. But before, I would like to remind you some things. Remember when we talked about limits of functions, right? We said that the limit as h approaches 0 of sine of h over h is 1, right? And also when, so these two here, so this guy here, but also we said that this guy here, the limit as h approaches 0 of cosine of h minus 1, everything over h is 0. Remember that? So if you don't remember this, go back to the lecture when we talked about limits of functions. And at some point, I told you something about the limits of involving trigonometric functions. But also there is one more thing that we would like to use in the proof of this, and this is, as you can see, this trigonometric identity. So this goes back to college algebra and trigonometry. So sine of alpha plus beta is sine of alpha cosine of beta plus cosine alpha sine beta. Right? And we would like to use this. So what tools do we have in our mind right now? So we have that the definition of the derivative. We would like to see what that is. And we would like to use these three facts, the red, the blue, and the green one, right? Those two limits and that trigonometric identity. So let's do it. So first, let's write the definition. So by the definition, we will write this in the following way. Right? As you can see, this is nothing else than just this definition, right? This is this definition right here. Oops. Sorry about that. Right here, right? For our function f of x is nothing else than just sine of x. Maybe I should write it here so that it's so f of x equals sine of x. Right? So as you can see, so this guy here is nothing else than just f of x plus delta x. And this guy here is f of x. And it's exactly the definition that you guys have here. Look, you see? This one here. All right. And now guess what I'm going to do? So I'm going to expand. What do you think I'm going to do? Can you tell me? So what do you think I should do here? Come on, tell me. What do you think I should use? I have that, you see, I have that thing over there, sine of x plus delta x. What do you think I should use?
The one circled in green.
Say that again?
The one that's circled in green.
Exactly, great. Exactly. So I'm going to use the identity circle in green because as you can see, I have the sine of x plus delta x there, right? All right, so I'm going to do that. Look what I do. I am actually doing it. And guess what? This will be nothing else than just the limit as delta x approaches 0 of, and now I'm using the green identity, right? And that will be sine of x plus delta x is sine of x times cosine of delta x plus cosine of x times sine of delta x minus sine of x and everything over delta x. So I'm taking this quantity here, right? So I'm taking this quantity here, and also I would like to see what happens when delta x approaches 0. And what do you think we're going to do now? So we use the green green identity, let's say. And what else do you think we should do now? Simplify. Can you be more specific? Yes, we'll look for like terms, exactly. So we will redistribute, yes, exactly like Diego says. So we will write it in this way, right? So we will have that, as you can see here, I'm going to take the negative sine of x, look here. So this guy here, I'm going to put it together with this guy here, right? And as you can see, I have them both together here. And I have plus this quantity. And now the limit of the sum is what? The sum of the limit, right? So let's see. What do we have? So we have the following. So I'm gonna, as you can see, so I'm gonna have there the limit, right? This guy here. So I'm gonna take out cosine of x here. I'm gonna take this out. And here I'm gonna take this, I'm gonna factor sine of x. And I'll have this limit here, as you can see in blue, right? Look at this guy here. But also I'll have in red, I'll have this guy here. Well, which are written below, and this as I pass to the limit as delta x approaches 0, so I'll have this quantity here, right? The limit of this guy here plus the limit of this guy here. Well, now what do you think this is going to be? Well, the limit as delta x approaches 0 of cosine of delta x minus 1 over delta x is what? Can you tell me? Is 0, right? As you can see it here. The only thing is that we, instead of h, we replace h by delta x. So this guy is 0, which is written here. And now in red, this guy here, now we're going to use this fact that the limit as h approaches 0 of sine of h over h is 1. And this guy will give me 1. Look at it here. So sine of x times 0 will be 0, right? And now the only thing that's remaining is cosine of x, which you find here. And that's the proof, right? Well, it's a little bit involved, I would say, because you have to know what is the derivative of sine and cosine. What is the, you have to know those two limits, sorry, and you also have to know that trigonometric identity in green. So this one here. All right. So in a way, for cosine, the proof is very similar. You can prove it in the same fashion, and I'll leave this to you as an exercise. And now I'd like to move forward with I hope you guys can hear me well, because it says to me that my internet connection is unstable. Do you guys hear me well? Is everything okay? Okay, that's good. All right. All right. Now I'm trying to go maybe a bit slower so that. Okay. Now let's see the following example, and I would like to draw your attention with the following derivative. And I will take a couple of minutes to let you do this one, and then we'll discuss it. So think about it for a couple of minutes. How this could be like a very this could be like a good problem for the gateway exam. So what do you think? What is the derivative of this? You see, we have a function there inside. So we need to take the derivative with respect to x of this quantity here inside, you see? So let's just say this is f of x is cosine of x plus 5x squared minus 7x. So how would you compute the derivative of this guy? Yes, Jonathan says, okay, okay. Wait, you forgot something. No, not quite. Please be careful. What? No, yes. So P, okay, that's more like it. So I see Frank, okay. All right, let's see. So the derivative of this, first of all, we will apply the sum rule, right? So the derivative, as you can see here, my function f is the sum of some other functions as well. We have a trigonometric function, which is cosine. We have a quadratic function, if you want, which is 5x squared minus 7x. All right. So by applying the sum rule, so here is the sum rule. And right, I would like to go back to the previous lecture. And then we will have that, as you can see here in red, we have the derivative of cosine with respect to x, right? Plus 5 times also the constant rule, 5 will go in front of the derivative. So it will be this guy here. So, right, the derivative of this is this. We'll have the derivative of this and the derivative of this. Okay. So this is nothing else than just the sum rule and let's say also the constant rule. Sum and constant rule as well. Okay. Now, what is the derivative of cosine with respect to x? Is what? Is negative sine, correct? What is the derivative of x squared with respect to x? It will be 2x, right? And the derivative of x with respect to x will be 1. And here we go. Guess what? We have exactly this, right? Is negative sine of x, which is this guy here. This guy here is 10x, and this guy is 1, but it's 7 times 1. Right, so once again, let me just say here, cosine of x prime is negative sine of x. X squared prime is 2x, and x prime is 1. So that's what you need to know. And that's the derivative. I'm going to write it again. So it's negative sine of x plus 10x minus 7. All right, so that's an easy example, I'll say. But now let me go, what if we would like to see, well, in this example, you saw just a combination of, well, a linear combination like sum, multiplying by constants and so on. So the only thing we had to use is just the sum rule and the constant rule, and also to know what the derivative of cosine is, which is pretty easy. But now let me recall the product rule and the quotient rule. So these two rules that we learned in the last lecture. So first, let me remind you that the product rule says the following. So the derivative with respect to x, right, of the product is not as you would imagine the product of derivatives, but it's a little bit more than that. So it's f, in fact, I can write it in this way so that you can guys see it. So this guy is f of x times dg over dx, right, plus df over dg times g of x, right? Or if you want, you can write it in this way, f, in fact, let me just use one color here, f times g prime, everything prime, is f prime times g plus g prime times f. So that's the product rule. So that's what you need to know. As you can see it here, so that's the product rule. Once again, the derivative of the product is f times the derivative of the g plus the derivative of f times g, right? Okay. Now let's see the quotient rule. You see the quotient rule, it will be similar to the product rule, but of course, if we take the derivative of the quotient, the result will be a quotient. And the rule says the following. So the derivative with respect to x of f of x over g of x is g of x times f prime of x minus f of x times g prime of x. Everything over g of x squared. Okay, so let me write this. I'm going to write it f over g everything prime, also in this way, which is f prime times g minus g prime times f, everything over g squared. So that's what you have to know, right? So this is the quotient rule. Okay, I want you to look again at these two rules. So look at them carefully, because we would like to use these rules in order to compute some derivatives, and the derivatives that we will be dealing with today will involve the product of, or the quotient of two or even more functions. All right, so let's start with a simple example, and a simple example that I have in mind is the following. So let's compute the derivative of this product. I want you to look at it and try to do it by yourself. And so think about it for a minute or two. Somebody, okay, Sabrina says it's 2x plus cosine of x. Let's see. Is there any other result? Let's see. Muhammad says 2x sine of x minus x squared sine of x. Okay. Like I said, please, let me stress this again. F times g prime is not f prime times g prime. Do not make this mistake. I see Isha here. Okay, plus, so it's yeah, it's similar to what yeah, Isha Ehsan, what Muhammad has. So keep that in mind. This is, you're in a danger zone when you do this. So once again, the derivative of the product is not the product of the derivatives for any two functions. That doesn't happen. So let's see here in this case. So as you can see here, we can identify f of x to be x squared if you want, and g of x to be sine of x. F prime of x is what? Is 2x, and g prime of x will be cosine of x. Okay, and now let's apply the product rule. So here by the product rule we have this. Here the product rule. Right, let me show you previously the product rule, what it says. Look at it. F times g, everything prime is f prime g plus g prime f. So keep that in mind. I see a question here. Let's see. No, it's fine. Don't worry about it. It doesn't matter. I mean, I don't care about computations. Well, as far as I'm grading, but you know, if you have an online exam, the system probably would like you to simplify. So, because it will be a multiple choice, so you have to see which one is it. And probably if you don't simplify it, if you do not simplify, probably you won't see which what to choose from those options. But anyway, as far as I'm concerned, in the midterm exam, which I'll be grading, I don't care about simplification. So I only care about the procedure. If you know how to apply and if you know what you're doing, that's enough for me. Okay, so right, keep in mind the product rule again. And now we will apply this here, and guess what? The derivative of this, you see, this guy here will be cosine, right? This guy here in red is cosine. And now this guy here, right? Look at this guy here, is this guy here. So that's it. So it's x squared cosine of x plus 2x sine of x, just like you guys said. All right, so that's the first example. As you can see, it was an easy one. So you should expect harder than this. What about, let's see a harder one. Look at this guy here. I want you to think of it for a bit. Of course, you can already identify which one is which one. So you can say that f of x is cosine of x, and g of x is 5x squared minus 7x. And you can compute the derivative of each one of these. So f prime of x is, the derivative of cosine is what? Is negative sine. And the derivative of g is, well, it's 10x minus 7. All right. So with this in mind, what should we use here? So the derivative of this product will be what? So here is f of x, and here is g of x. So what should we apply here? What did we say earlier? The product rule. By the way, I see only a couple of people answering. I would like to stress this, that it's in your advantage to answer, even if you answer wrong, because I'll remember your name. me remembering you, it will only play in your benefit. Because, it's kind of hard for me to remember. I try to, while I'm teaching, I'm trying to look at you here through Zoom, but I only see just a small, so I try to remember your faces. And if you answer, even if you're vocal with your answers, I will definitely remember you. So if you answer a couple of times, then definitely I will remember you. Okay. So now we're going to use, just like you guys said, the product rule. So let's do it. And look what we have. So this guy here, you see, this is F. This is G prime. This guy here in red is F prime, right? And we already computed it. And here, this guy here is nothing else than just g of x. As you can see, this is nothing else than just the product rule. So here we apply the product rule. Okay, that's great. So let's see. We already computed the derivatives. As you can see, they're here, both of them. And I'm just going to replace them. So this guy here is the derivative of this, right? And this guy here, right? This is the derivative of this. Oops. And that's it. And now you can do the computations if you want. I don't want to go into that. So I'll leave it to you. So the derivative is nothing else than just cosine of x times 10x minus 7 plus negative sine of x times 5x squared minus 7x. If you want to do the algebra here, be my guest. Go ahead. I'm not going to do it. Okay. So that's an example. But now I'd like to find the derivative of something that you see here. For example, I would like to find the derivative of the tangent function. And as a hint, as you can see, the tangent function, keep in mind, that is nothing else than just the quotient of sine and cosine. So what would you suggest here, since this is given? So what would be your suggestion? How do we find the derivative of this? So basically this would be nothing else than just the derivative with respect to x of sine of x over cosine of x. So what would you do to find the derivative of the tangent? Right, so is this here. Exactly like Jake says, we will apply the quotient rule. So let me remind you the quotient rule. Exactly, so it will give you a secant square. Anyway, we'll go there. So it's f over g, right? Everything prime is f prime times g minus g prime times f, everything over g squared. This is the quotient rule. And in fact, if you would like to go back, look at it here, right? The product and the quotient rules, both of them, right? So now, going back, so by applying the quotient rule, guess what? We have this. So in our case, we identify f of x to be, f of x is sine of x, and g of x is cosine of x. So f prime of x is cosine of x, and g prime of x is negative sine of x. So we have this here, so let's keep this in mind. So this will give us, as you can see, this guy here. So the derivative of the sine here is cosine here. And also the derivative of the cosine here is the negative sine here. Right? And now it's just algebra, so it will give you cosine squared plus sine squared on the top, and on the bottom is 1 over cosine squared. But these two guys here, always keep this in mind that this guy is 1. The sum of the squares is 1, which you find it here. And this is nothing else than just 1 over cosine of x squared. And this guy is secant squared of x. In other words, what you need to remember, or maybe you don't have to remember, but if you forget how to find the derivative of the tangent, you can also apply the quotient rule and you'll find it. So the derivative of the tangent is secant squared, or if you want, is 1 over cosine squared of x. So keep that in mind. And now, in a similar fashion, you can do the same thing for the cotangent, and I'll leave this to you as an exercise. So as an exercise, find the derivative with respect to x of the cotangent of x. So it's the same thing. You'll use the quotient rule again, but this time you'll reverse the two. So it will be cosine over sine. And you'll do the same thing. You'll go through the same thing. You already have the derivatives of sine and cosine and so on. All right. Well, it will give you, it will give you nothing else than just negative cosine, cosecant squared of x. But anyway, I'll leave this to you as an exercise. All right, now putting everything together, we have the following derivatives of trigonometric functions. So let's gather all of them, and you will see that we have this. So once again, the first two that we have seen at the beginning of the lecture, sine and cosine. So the derivative of sine is cosine, the derivative of cosine is negative sine. Then, as we have previously seen, the derivative of the tangent, so by applying the quotient rule, we'll get that the derivative of the tangent is secant squared, and also in a similar fashion, just like I said, it's a good exercise for you to do. The derivative of cotangent is negative cosecant squared of x. And if you want to go even further, you can actually prove that the derivative of secant is secant times tangent, and also the derivative of cosecant is nothing else than just is negative cosecant times cotangent. So in a nutshell, these are the derivatives of trigonometric functions. Ooch. So this, please keep this in mind. Well, it's easier to remember them, but if you don't remember them, you know there is a procedure how to deduce them. Okay, I want you to stare at them for a moment. You can photograph this. Anyway, you'll have the video afterwards, so you can look at the video. And now, well, let me go with another example, with some other examples before we move into, and before we discuss about the derivatives of the exponential. I'd like to do examples involving tangent and cotangent, and secant and cosecant. All right, so the first example that I have in mind is the following. So find the derivative with respect to x, right? So in this case, f of x is 2 tangent of x plus 3 plus cosecant of x minus x to the fourth. So we would like to find f prime of x. So what is this? So that's what we're interested in. So I'd like you to think of this for a couple of minutes. So, what do you think we should do? I see some. Oh, let's see. Somebody. So, exactly. Yes, Isha. Yes, I think, yes, correct. Both, all three of you, Isha, Sabrina, and Eric, correct? So let's see. First, let's go step by step. We will use the sum rule, the sum and the constant rules, right? So here we use sum and constant rules. Right? In other words, the derivative of the sum is the sum of the derivative. And now, once we do this, as you can see, I will end up with, I'm going to take the constants out, but you see here, I will have the derivative of the tangent with respect to x. And here, this guy here will be the derivative of cosecant, right? You see them here, but you also see the tangent here. Anyway, you don't care about the constants, you just take it out. But also, right, you see this guy here, which is this guy here. All right, now we know what the derivative of each and every one of those is. So let's see. So the derivative of the tangent will be secant squared, as we have seen. You guys see it here. The derivative of the cosecant will be nothing else than just cosecant of x times, well, negative, by the way, let's pay attention. This guy here is with the negative, you see, let's not forget about that, right? Let me go back and look. The derivative of the cosecant of x is negative cosecant times cotangent. Right, as you can see here. And now this guy here is 4x squared. The negative was already there. And that's it. So just like you guys said. All right, so this was an easy one. Well, let me do a one that's a little bit more involved. All right, I want you to look at this guy here. What do you think of this? So we have to compute the derivative. You see we have the product of two functions there. So what would you do? Look at this guy here. This will be, let's say, like an f of x. And this guy here will be like a g of x. And we can write the derivative of each and every one of those, right? And let's do it. So, but first we will apply what? What do you think we should apply? So when we have to compute the derivative of the product of two functions, we apply constant, but we'll apply that after the product rule first, and then exactly. So we will apply the here, right? As you can see, this is f of x. Look at it. Look at this guy here. And now, whoa. You see, I have the derivative, right, of g. This is g prime of x. And now I will have the derivative, this guy in green here. This is the derivative of f. And this guy here is nothing else than just g of x, right? As you can clearly see, this is nothing else than just the product rule. So let me write it here. So here's product rule. And now let's do it. The derivative, let's compute the derivative. And the derivative, as you can see, of this guy here is you can apply the sum rule. So let me be more specific here so that you guys can see, because the derivative of this is this here. But let me be specific. So g prime of x, so is the cosecant of x plus x to the fourth prime, will be cosecant of x prime, so I apply the sum rule, plus x to the fourth prime. And this guy here will be, let me put it here, this guy here will be what? Cosecant prime is nothing else than just negative cosecant of x times cotangent of x plus 4x cubed. Right, so you guys can see that here. And now the same thing will happen here. You see this guy here. This is the derivative of this. Because f prime of x is nothing else than just 2 tangent of x plus 3 prime. And this is 2 times tangent of x prime plus 3 prime, which is the 3 prime will be 0. So it will be nothing else than just 2 times tangent of x prime, and that will be 2 times secant squared. You guys see there. And now the rest is just algebra. Like I said, I don't want to do it. So that's an example of the product rule involving trigonometric functions. All right. Let's go with another example. This time I would like to, I have the quotient of two functions. So what do you think I would do here? Instead of applying the product rule, I will apply what? The quotient rule, exactly. So in this case, I will have that f of x is secant of x, and g of x is 1 plus tangent of x. And I'll apply the quotient rule. So let's do it. As you can see here, here I'll have the derivative of this guy, the derivative of x. So this is f prime of x. And here this guy will be just the g of x. Then here I'll have f of x. Here is the negative times, and this guy here in green, this guy here is nothing else than just the derivative of g of x. G prime of x. And here on the bottom, we have this is g squared of x. Oops. Right, this is just the quotient rule. And now let's compute the derivative of each one of them. And well, the derivative of the secant, as we know, is this guy here, secant of x times tangent of x. And the derivative of 1 plus tangent of x, so it's the derivative of 1 plus the derivative of the tangent of x, but the derivative of 1 being a constant is 0, so it's not, we're left with the derivative of tangent of x, which is secant square of x. And you guys will find it here. All right, you already have a secant, and then you can do the algebra. I'm sure you can do it. I don't want to lose time with that. Okay. Yes, exactly. Yeah, just like Cameron says. Yeah. Mm-hmm. Yeah. Is everything clear so far? Any questions? Okay. All right. I hope it's all good for everyone. Like I said, don't be shy in interrupting me if you don't understand something. All right, now let's veer towards exponential and logarithmic rules. And that's what, these are the two rules, the two basic rules that you guys need to know. And anyway, we will see examples involving these. So what we need to know is that the derivative of the exponential of e to the power x is the same, so it doesn't change. And the derivative of the natural log of x is 1 over x. So we can write this as e to the x prime is e to the power x, right? And ln of x prime is 1 over x. That's what you need to know. I want you to stare at them a bit, right? They're very easy to remember. Anyway, you can, if you don't remember them again, you can use the same technique to find the derivatives by using the definition of the limit and so on. It will be quite easy to do so. So once again, e to the x prime is e to the x, so it will stay the same. And ln of x prime is 1 over x. All right, now let's see some examples. I hope you guys can hear me well because, again, my internet is playing around with me. So let's see the following example. Okay. So what do you think? What do you think we should do here? So what do we have here, first of all? So we're asked to compute the derivative of what? Well, some people already went. Oh, okay. They went ahead. Yeah, probably, yeah, that's... we'll see. So first of all, we have two functions here. We have the product of two functions. The first one is e to the x, and the second one, g of x, is cosecant of x. All right, and we like to compute the derivative of this. So first of all, what is the derivative of e to the x? Well, as we have previously seen, look at it, it's e to the x. So this is e to the x. And g prime of, and what is the derivative of cosecant of x? So it's negative cosecant of x times cotangent of x. Right? So now let's apply the product rule. So by applying the product rule here, we will have that, as you can see, this is the derivative of, this is g prime of x. This guy here is f of x plus this guy here is the derivative of sorry, f of x. And this guy here is nothing else than just g of x. Okay, so this is the product rule. And now, as you already know the derivatives of each one of these two, so we're just going to plug them in. And indeed, we will get that this is, will give us this. This is the derivative of this, and this guy is the derivative of this. And that's the result. And you can factor e to the x, as I've seen here in chat, let's see. Anyway, yeah, you can factor or you can leave it like this. Right, so that's the result. All right, let's see some other two examples. Let's see another one. I want you to look at this. So we have to compute the derivative of ln of x times tangent of x. So again, what do you think we should do? Well, again, we have the product of two functions, right? And the first one is involving, so f of x is ln of x, and g of x is tangent of x, right? And we know that f prime of x is 1 over x, and g prime of x, so what is the derivative of the tangent? Is what? Secant squared, right? So now by applying the product rule, we have this. So here again, we apply the product rule. And we have the derivative of the, okay. Anyway, it doesn't matter which way you, so this is g prime of x. This guy here is f prime of x. And these two guys here, so right, we have a plus, this is times g of x. And here, this is f of x. Right, so this is the product rule. And now, since we know what the derivative of each one of these two is, so in this case, we know that the derivative of the tangent is secant squared, and the derivative of ln is nothing else than just 1 over x, which you'll find here. And the result is this. So it's ln of x times secant squared of x plus 1 over x times tangent of x. Anyway, you can leave it like this, it doesn't really matter. Right? Is it clear for everybody? Do you have any questions regarding this example? All right, I'm glad everything is clear. I hope so it will be the same at the exam. You will tell me how easy the exam was. All right, now let me draw your attention with another example, and probably after this I'm going to stop. Okay, I want you to think of this guy here. Now I'll give you a couple of minutes. Let me just stretch a bit. So what should we do? So let's see. Yes, Frank, Eric. Yes, exactly. So it's a combination. But first, what would you apply first? What is the first rule that you apply? So as you can see, it's a combination between the quotient rule and the product rule as well. But what is the first thing that you would do? The quotient rule, exactly. So first, let's identify. So this is it's a little bit tricky. So let's identify this as f of x, and let's identify this guy as g of x, right? So, and we're going to use the quotient rule. So let me write it here. F of x is ln of x times tangent of x, and g of x is x squared. And of course, when we will compute the derivative of f, we will use the product rule. But first, let's use the quotient rule, as you can see here. So here is the quotient rule. And of course, you can identify easily. This is the derivative of f, right? F prime of x. And this here, this guy here is nothing else than just a derivative of g prime of x. And here we have f of x. This guy is f of x. And here is just g of x. Okay. So we apply the quotient rule. And now we will just compute the derivative of each one of these. And now let's be careful here. Because here, and this parentheses here, I'd like you to look at this guy here. Actually, we should do it by hand, separately. The derivative ln of x times tangent of x will be, so here I'll apply the product rule. Product rule here. As you can see, let me just write it in this way. So let's just say that this is a function g, oh no, a function s of x, let's say, is ln of x, and r of x is tangent of x. And by applying the product rule, you see here you have you have s of x, and this guy here will be r prime of x, and this guy here will be s prime of x, or s prime of x, right? So we apply here the product rule, and then at the end of the day, we will end up with this result. So the derivative of the tangent, right, will be secant squared that you guys see here. Look at this. And the derivative of ln of x will be 1 over x that you guys see here.
I have a question.
Yes, Cameron.
Will there ever be a time that you would use the product rule first?
Yes, that's a very good question. So there might be a situation when well, for example, so that's a good question. So let's see. So when can we use the product rule first? And now let's answer the question. Well, for example, let me cook up an example. So find the derivative of, let's say, d or dx of sine of x times, let's say, 1 over x, look. I can use the product rule here, or you can use the quotient rule. You can use both of them. It doesn't really matter. So you can identify this as f, and this guy is g. And you can apply the product rule. So apply the product rule. But you can also see this as, but we can also see it as a quotient. Well, when we see it as a quotient, what do you think we're going to do? So we can write this as, so d over dx, let's say sine of x times 1 over x, can be seen as this, sine of x over x, and you can apply the, and here you apply the quotient rule.
So is it always going to be okay to do just quotient rule first?
Yeah, exactly. Or you can do the product rule. Even if we go back to this example that we had here, look, you see, finding the derivative of ln of x times tangent of x over x squared. You could have written this, but you know, here is the situation. It's not convenient for you to apply product rule.
Okay, that's what I was wondering, if it was just like not possible, or if,
no, it is possible. No, it is possible, but it's not. It's not. I mean, it's much more involved. It will take you a lot longer to compute derivatives. For example, you can write this as. Look, you see, you can write this also as the derivative of, let's say, ln of x over x, or ln of x, okay, over x squared times tangent of x. And you can apply the product rule, right? Right, for this one here and this one here. But once you apply the product rule first, you have to, when you compute the derivative of ln of x over x squared, you have to apply the quotient rule. So either way, it doesn't really matter. It's not like necessarily you have to apply the quotient rule and then the product rule, but it will be more convenient for you to do the quotient rule because it will make your life easier when you compute derivatives. Does this make sense? Okay. Any other questions regarding this example, or? So like I said, it doesn't really matter the way you. All right, if there are no examples, I think I'm gonna stop here. Feel free to come to my office hours in like 10 minutes. Like I said, the link is different. Is my personal ID meeting. So look in the email if you wanna find it. Okay, guys, I'll see you. Take care. Bye-bye.